All right, today we're looking at the key attributes for linear functions. So the first thing that we have to identify is the slope. And remember, slope is rate of change. Slope can be one of four states. It can either be positive, negative, zero, that means it's not going up or down, or this, which is undefined, which we can abbreviate with UND. Okay? Because slope is how fast a linear function, or any function really, how fast a function is moving up or moving down or not moving at all. But here, when it's undefined, that at that point doesn't even pass the vertical line test. So that's not even a function. Okay. To find slope, we take the rise over the run. So this is the change, this like triangle here. This means change in y over change in x. How fast it's going up or down divided by how fast it's going left or right. And then we write it in this form right here, slope-intercept form. So, couple key other attributes are intercepts. There are two intercepts on every single graph, or two possible intercepts, I should say, on every single graph. There's a y-intercept, which is found right here. It's where it crosses the y-axis. Yeah, I'm going to write this in a different color. I'll keep slope in blue. We'll go green. The y-intercept, which here we never know exactly where it's coming through the y-axis, so we don't know what that is, but we always know what our x value is going to be, because our x value is not going to be positive, it's not going to be negative, it's going to be right here at 0. So for the point, it's always 0 comma and then whatever it goes through the y-axis. So like here, this would be 0 2. My x value is 0 because I didn't go left or right, and I just went up 2. Now the other scenario is if it goes through this, which is the x-axis right here. So for the x-intercept, again, the x would have a value here, some number, but our y, it's not above the line, it's not below the line. Our y value is always 0. So right here, this would be 3 comma 0. Now, one other thing that we need to know is oftentimes the x-intercept has different names attached to it. One of the names that we use very common is a 0. What that means is this is the value of the function when it hits the x-axis. It's when the function hits 0. So we call it a 0. It's when the function itself is at 0. Not a positive value, not a negative value. It's at 0. Okay? So, identifying key attributes. When we have a graph and we want to identify these key attributes, let's start with the y-intercept right here. So we look for where it's crossing the y-axis. Right here, it's crossing the y-axis at 2. So my y-intercept is a point, so I write it as 0, comma 2. The x-intercept is where it's crossing the x-axis. So this is 4, comma 0. If it's ever asking for a 0, again, this could be the point 4, comma 0, or we could just say x equals 4. This is the value of the function when the output is 0. When output is 0. That's why we use the term 0. Again, mathematicians are lazy, so we're going to use the most easiest names that we can possibly name. So now here's how we find slope. Okay? First thing we want to do is we want to identify, is this going up or is this going down? If this is going down, that means my slope is negative. So I know my value is going to be negative. Because this is going through at two intercepts and they're nice, neat integers, we're going to use this to our advantage. Because we would go down 2 over 4. And 2 divided by 4 reduces down to negative 1/2. So that's our slope. Our slope will be a number. Our y-intercept will be a point. Our x-intercept will be a point. Our 0 could be a point, or it could just simply be x equals. When we're given a table, we have to find our y-intercept, our x-intercept, our 0, and our slope. So again, we're going to start with y-intercept. Remember, y-intercept, we look for when x is 0. When x is 0, y is 4. So my y-intercept is 0, 4. My x-intercept happens when my y value is 0, which is right here. So that's 3, 0. Again, my 0 could either be 3, 0 or x equals 3, because remember, it is when the output is 0. Remember, these are my outputs. So it's looking for the input value when the output is 0. Now the slope. Okay, so remember, slope can be identified as the change in y divided by the change in x. How much these values are changing every single time. Now, the nice thing about a table is you can pick whatever values you want. So me personally, I'm going to pick these values. And here's why. You see this? That's a -3. I don't want to deal with a negative. This one has a -4. I don't want to deal with a negative either. So what I'm going to do is I'm going to start here. And I'm going to say, okay, what do I have to do to go to this guy? If I'm at 0 and I go to 3, I would have to go up 3. Okay, this is my x value. So this is going to be on the bottom part. I'm going to do the same thing with y. If I start at 4 and I went down to 0, that means I went down 4. So this is -4. Okay? So now what I can do is I can look at this and be like, okay, -4/3, that can't be reduced. I'm going to just leave it like that. -4/3. Okay? Don't convert this into an improper, or keep it as an improper fraction. Don't convert it to a mixed number or anything like that. Just leave it as a fraction. If it cannot be reduced or it cannot be simplified, we just leave it. Now, the nice thing about this method is it doesn't matter which points we pick or which direction we go. If I went this direction, 3 down to 0, or I went this direction, 3 up to 6, that's +3, it doesn't matter which directions I go, the value is still going to break down to being the same. The only way that this would even change is if I went and skipped over some points, and then all I'd have to do is reduce anyways. Okay, so again, here's how we find our intercepts when we're given an equation. We can either set our x values to 0, set our x value to 0, or y value to 0 to find the x-intercept, set the x equal to 0 when the y-intercept. So first, I'm going to look at this. This is slope-intercept form, which is y equals mx plus b. Okay, so m right here. Ooh, I'm going to change a different color because my y-intercept has been consistently green. I'm going to switch to purple here. This is my slope. So right here, I have y equals, and I only have one x value right here. It just happens to be negative. So I have -1x plus 3. So this right here, this is my slope. So my slope is -1. That's it. It's done. My y-intercept, here's a nice thing about y-intercept on this. Because it's written in slope-intercept form, this happens to be my y-intercept. So this y-intercept is 3. So 0, 3. The x-intercept is a little bit harder to find in this form. You have two options. One, you can graph it and look for where it crosses and click it. Okay, I can't show you that using the camera. But what we can also do is if I'm looking for the x-intercept, I set my y equal to 0. So I would say 0 equals -1x plus 3. And I solve for x. The first thing I would do is I would subtract 3. I have -3 equals -1x. Divide by -1. I have 3 equals x. So my 0 is x equals 3. My x-intercept is 3, 0. So they happen to have similar x and y intercepts. My y-intercept is positive 3. My x-intercept is also positive 3, which happens because the slope is negative 1. So it's nice and balanced. Okay, here we're given standard form, which is going to be a bit more complicated. Okay, so in standard form, because it's not written in slope-intercept form, okay, we'd either have to convert it to slope-intercept form or do something else to find the slope. Here's what we're going to do. What we're going to do to find the y-intercept is we're going to say, okay, my y-intercept, or my x-intercept, sorry, we're going to start with x-intercept because that's the first one that's given up here. My x-intercept, I set y equal to 0. So I say, okay, 5x minus 2, I make my y value 0 equals to 10. Well, 2 times 0 is 0. And 5x minus 2, or 5x minus 0 just goes away. This is why we like using 0. It eliminates stuff. So I have 5x equals 10. I divide by 5. I get x equals 2. So my 0 is x equals 2. My x-intercept is 2, comma 0. Now to find my y-intercept, I do the exact same thing, but in this time, instead of making my y 0, I'm going to make my x 0. Now, another way to think of this is I'm going to set the value to 0 of what I'm not looking for. I'm not looking for the x, I'm looking for the y value and the y-intercept, so my x becomes 0. This goes away. Negative 2y equals 10. I divide by negative 2, divide by negative 2. I get y equals negative 5. So my y-intercept is 0, comma negative 5. Now, because I have my y-intercept and my x-intercept, now I can go ahead and find my slope. Now, one of the things that's given to us is our slope formula, okay? y2 minus y1, x2 minus x1. And so what we would do is we would take our y values and subtract them. Negative 5 minus 0. And then we take our x values and subtract them. 0 subtracted by 2. And you notice how this point right here, I listed it as 5 minus 0. 0 minus 2. Okay? This has to be consistent. These have to line up with each other as the points. 5 minus 0 is still just negative 5. 0 minus 2 is negative 2. And a negative divided by a negative makes a positive. And 5 over 2 cannot be reduced, and I'm going to leave it just like that. Or what you could have done, I'll show you another way that we can do a regression. So in that way, that can help you with that. Last one, real world problem. Interpreting tree graphs given a real world situation. The graph shows the height of y in meters of a helicopter as it descends in x seconds. Identify and interpret each attribute. The rate of change, which again, this is just slope. My y-intercept and my x-intercept. Well, my y-intercept is pretty straightforward. It's right up here. And it looks like this is 5, 10, 15, 20, 25, 30, 35. So my y-intercept is 0, comma 35. Ooh, gosh darn it. I've been writing in green every single time for my y-intercepts. My x-intercept, that guy I've been writing in orange. It looks like it goes through right here. This is 0, 1, 2, 3, 4, 5, 6, 7. So 7, comma 0. So to find rate of change, I find the difference in my y's. So 35 minus 0. I'm going to write that in orange. Divided by my difference in x's. So 0 minus 7. I tried to do this in a order with the colored pens to show you where these numbers are coming from. But what I'm doing is I'm subtracting this value by this value, divided by this value, subtracted by this value. So 35 minus 0 is 35. 0 minus 7 is negative 7. 35 divided by 7 is negative 5. Which, by the way, this makes sense. because as it goes from left to right, my slope itself is negative. All right, and that's our notes for rate of change and key attributes.